AC won't turn on. Maybe the fan spins, but you're just not getting cold air into the house. Let me show you how I fixed my AC problem. First off, that's going to be a capacitor right there, and that's going to be a contactor. We'll be talking about these. You can see where it says fan there on the capacitor, and you see where it says Herm, meaning hermetic, which would be the compressor down here. We've got our thermostat wire that runs out here that activates the contactor. And of course, we've got our disconnect here, which is on because that fuse little link is installed. Let me pull this out and show you. This is what makes contact inside of these. And if we look inside here, you're going to pretty much see where you have line and load. So the wire that is coming from our house would be the line side, that Romex right there. And it's running up, and the load side would be the red and the black in the middle that runs through this flex and goes to our AC unit. This would be a really safe spot to check voltage to make sure that you have power getting sent out to your unit. And probably one of your first steps, you want to make sure that you have voltage here. Should have 240 volts line to line, 120 if you go to that ground, to each individual hot. We plug that in, it makes contact across all those copper connections, and now we can get voltage sent to our AC unit. If you've got voltage here, chances are you've got a control issue, and this was my next tell. For me, my contactor was sucked in, meaning that if I push this in, the fan should start up, and it does, and when I let it go, you can see where the fan is turning off. You can no longer hear it running. That's another good sign that your capacitor here is working. I went ahead and changed mine out while I was at the supply house, like 20 bucks. Emergency service call might run you close to 200. So we've got 240 volts. We want to make sure that the 24 volts is working. A good way to check is to push in your contactor. If your fan doesn't run, it could be your capacitor. And the way to check if your fan doesn't want to run is to stick something long down in there like a screwdriver. Do it safely. And when it's being called, meaning the thermostat is sending the voltage out to the contactor is trying to suck in, that would be a call for the fan to turn on. You can take your screwdriver and spin this blade, and you're acting like what the capacitor kind of does. It starts with the starting torque and helps the fan get running. And you can spin these fan blades manually, and this fan should start right up. If you pull this out and you kill the unit here, your contactor is going to pull out. You can plug it back in, and if the same thing happens again where you have to manually start the fan up, you're going to know you got a bad capacitor for your fan. See where it says fan there? But that wasn't my problem. That's just a scenario I've ran into before. Let's look at the contactor. We're going to have 24 volts, so we're going to have two wires. You can see where they really botched my installation here, but all they needed was two wires here. And if you don't have a heat pump, that's all you're going to have. You might have an additional one for your reversing valve, but we're not going to get into a heat pump. We're just talking standard AC. So they transfer from that wire to this wire, and if we follow this, it actually turns into this yellow and this blue wire, which go to either side of the coil on our contactor. There's the blue one on this side, there's the yellow on that side. You can check that side of the contactor for 24 volts if you suspect a transformer. And once you've verified that, you can simply just push this button in, and this thing should start right up. Let's go look at these components on a workbench, and I'm going to show you how they work and how to check the farads on this. We'll go ahead and look at the contactor first. This contactor here had a cover we had to remove, and you can see we can access the plunger right now. It's recommended when pushing the plunger that you use an insulated tool. Also recommended to be, fairly competent in what you're doing and kind of know what the components are before you stick your fingers in anything energized. We look here, there's the coil that we talked about on either side. And then basically what happens when this gets energized, when these here get power on the side, you have your line and you have your load side. When this pulls in, it automatically connects this side to this side, sending power through. So to know if this is bad, there's two things you can do. You can take your ohm meter and continuity, read across these coils, and if you don't get a beep, you know that the coil is broken. Or with the power on and the call, when I say the call, we're talking about the thermostat has sent the power to this device. So we should have voltage here now. You should get 24 volts here to here. And if you don't, you know that you don't have your control voltage, so it could likely be a transformer that feeds your thermostat. If you do have voltage here and this contactor is not sucking in, you know that the contactor is bad. When you replace this, make sure you match the amperage from the original. In this case, this one is rated for 40 amps here. Now, capacitors are a different animal. I recommend you don't touch any portion of this capacitor on the top. This 45 is a farad rating, U being micro and then F for farad. So this is 45 microfarads and 5 microfarads. So you got 45 for the compressor and 5 for the fan. If we look up here, that Herm right there, that is the compressor, and you're going to see the fan right here. This is the common. Go from your common with the multimeter in microfarads to the fan, and you should get 5. If we go over here from point to point, we're going to get 45. This capacitor is good. One way to know if a capacitor is bad, it'll be kind of bulged out, disformed, and also you won't really know how to tell until you set it on a table. I've held capacitors in my hand that were in fact bad, but you just couldn't tell until you put them on a nice flat surface and they had a little teeter to them. Using a tester is a surefire way to know if your capacitor is bad, but like we mentioned before, if your contactor is sucked in, you've got the call, you got all the voltage, and the fan does not start, that's also usually a pretty good sign. In my case, my problem wasn't either my contactor or my capacitor. My problem had to do with the controls inside my AC unit, where I actually had a stopped up drain line, and to prevent the house from flooding, my controls was not allowing the compressor to run. So if we go to our AC unit here, you can see where this is the float switch here. And this float switch should be completely dry. If you have any water in there, that's likely going to be your problem. You'll need to blow out this drain line. Most likely an HVAC tech will need to put some CO2 on this line to blow it out properly. And that was my problem. These controls were preventing this board from allowing my compressor to turn on. Hope that helps. Try all those tips out, and we'll see you guys in the next one.